but we lost counting the days. Rather, we are counting the moments that we are passing through, which is so interesting and encouraging.
Thank you very much for inviting.
Inexhaustible energy to our organizing chair, Sival sir. Unite. So that makes.
Thank you, sir. So I think we will start with our, as usual, our symbolic lamp lighting.
Yes.
Yeah. What I will do is I will mute all participants actually, because it is not that we don't want to give the freedom, but in between the talk, no, sometimes, sometimes some sounds may come. Yeah, it is 5:59. So in few seconds we'll start. So we will again unmute all the participants after the session, because in between, no, otherwise unknowingly if somebody clicks, no, there may be some sounds, especially when we have a large number of participants, and all the co-hosts can control themselves. So they have that control to unmute themselves. We'll start, sir. Namaskar and very good evening to all of you from India, and good morning, good afternoon to all the participants wherever you are. Well, welcome to the keynote session 8 of virtual conference on disaster risk reduction, civil engineering for a disaster resilient society. Welcome to all the speakers, welcome to all the participants, and welcome to the chairman of this session, Dr. Raju Sarkar. So let me briefly introduce the chair. Dr. Raju Sarkar is a professor at Delhi Technological University, and his expertise includes geotechnics for natural disaster mitigation, soil structure interaction, pavement geotechnology, environmental geotechnics, etc. He worked as a quality control engineer in L&T for the Delhi Metro Rail Corporation Limited DMRC project. He also worked in the Royal University of Bhutan. He has published several research papers in international journals of repute, and he also authored 2 books and acted as a reviewer for several journals. He has 2 patents to his credit and has carried out several funded research projects. With this brief introduction, I now hand over the session to Dr. Raju Sarkar. Please.
Thank you, Dr. Silvasa, for giving me opportunity to chair this really great session, and I'm really congratulated once again for organizing such a big conference of very important issues related with at present that the countries like India, as well as countries that we are facing of the various issues of the natural disasters. And I'm really happy to see that civil engineering is a part of the disaster recovery issues, risk reduction stages that we are already associated with. So thank you once again. I'm really happy to have our 4 experts today, starting with Professor ML Kansal, then Dr. S. Nilamani, and Dr. Alexandro Facetti, and Dr. Penan Chinnaswamy. So today I would like to invite first in this session to Professor ML Kansal. He is a civil engineering graduate with a post graduation in water resource engineering, PhD from Delhi University, and a PhD postgraduate diploma in operation research. And happy to share with you that he was my senior in Delhi Technological University. That time it is called Delhi College of Engineering. So happy to see Kansal sir once again in this platform. Previously, he worked as a WRD and M department, and he's a chair professor also there, as well as in his Delhi College of Engineering, then NIT, then IIT, and NHA Roorkee. He has published more than 150 research papers and 2 books, and has acted as a reviewer for several international journals and research agencies. Dr. Kansal is also an ex-vice president of Indian Water Resources Society and served as expert panel member for AICT India. He has contributed substantially by providing consultancy services to various national and international agencies of repute. So I'd like to welcome for this session to Professor M.L. Kansal sir. And in the meantime, I'd like to request all the participants that please, if you have any questions related to the presentation, or you want to know something more about our eminent speakers the presentation, please write down your query in the chat box so that I can take up your queries just after the completion of the presentation of each and every speakers. Thank you. Kansal sir, now dais is yours. I have used the word dais because it's virtual, no doubt, but I'd like to ask you to please take over the podium and start your presentation. Sir, your mic is switch off. Can you unmute it, please?
Sir, you can just click the unmute button on the left bottom, because you are co-host. You can mute yourself. Otherwise, I am asking you to unmute.
Okay.
Yeah, perfect.
Now it's okay?
Yes.
Okay, friends, good afternoon to everybody. And I'm thankful to the organizers for giving me this opportunity to discuss with you some of the issues related with the cloudburst, a major disaster in this part of the country. Basically, as we... Yeah, I think I hope you can see my screen.
Sir, you have to reshare, because I have shared for the speaker bio, no? So you have to reshare. Yes, yes.
Let me just...
Yeah, please.
Yeah. Yes, I hope you can see now.
Yes.
Okay. I'm sorry for the little disturbance because of that. Basically, as you know that IIT Roorkee is in the state of Uttarakhand, particularly in the Indian Himalayan state. And cloudburst is a major disaster in this area. In fact, the Indian Himalayan states spreads over 12 states and 1 union territory. That is the latest one, the Ladakh. The 3 major graphical entity like the Himadri, Himachal and Siwaliks are 3 basic components of the Indian Himalayas. Various mighty rivers like the Ganges, Indus, Kosi, Brahmaputra and other originate from the Himalayas. Some of the highest mountains on the earth are here, and major geographical fault lines lie here, and geology is very fragile here. So therefore, this is basically it is the numerous natural hazards are occurring in this area. Basically, the cloudburst, when we are talking about, is a sudden aggressive rainstorm which is of small duration, maybe few minutes to few hours, just like this small video, you can see it here. These are characterized by very high intensity rainfall, maybe more than 100 millimeter per hour, within a very shorter duration over small area, ranging from 20 to 80 kilometers, usually occur in steep orographic regions during the, and it has been noticed that these are generally occurring during the monsoon season. And it may lie up to 15-kilometer height in cloud-based like systems, generally occur in inaccessible hilly areas and are not reported until a significant socio-economic disturbance is caused by the subsequent flash flooding and the landslides. Why the and how the phenomena occurs? One of the basic thing is basically the low level convergence of southeastier and northeastier winds, like southeastier and northeastier winds, coupled with vertical shear in the wind that is taking place, and the orographic lifting is causing the cloud formation. Then it leads to a short-lived, intensely precipitating convective storm cloud burst. So this is how the dynamics of the cloud burst is there, particularly in the North Himalayan area. The various reasons for such incidents may be categorized under three categories. One is the climate, second is the orographic, and third is the anthropogenic cause. तो कैसे खत्म करूँगा इसको? I'm just इसको हटाऊँगा कैसे करूँगा? Okay. Sorry, just a pointer problem was there. Under the climatic conditions, if we see that the various issues are, one is the air temperature, and we know that in Himalayas generally the air temperature in winter it is -5 to almost 5 degrees, whereas during the monsoon season this may be varying from 10 to 20 degrees. So increase in temperature increases the atmospheric humidity and lead to the extreme rainfall occurrence. Second is the pressure. Naturally, the cloud formation and movements takes place because of the difference in the pressure. So air rises in areas where the pressure at the surface is low, and clouds, precipitation, and bad weathers are mainly associated with the low pressure systems. The precipitation generally takes place, particularly in this part of the country during the monsoon season, and the monthly precipitation ranges from 150 to 600 millimeter in Uttarakhand. So active monsoons are the most common extreme rainfall events in the Himalayas that occur every year. Then orographic regions are, as we know that from the sea, the warm and humid air moves upward. Then it continues to rise the air mass, forming the large clouds. Then the water concentration increases in the clouds when it goes up, and then it increased concentration of water cause sudden localized downpour of the water. And during the because of this sudden downpour, the steep slopes and lack of vegetation cover causes the flash flood. This is how these phenomena and its effect are taking place. Then also most of these precipitations or the changes are related with the elevation, and it has been noticed that most of these cloud bursts takes place between the elevations of about 2000 to 4000. So all these formation of the aerosol depth or the surface pressures or the mean air temperatures, all these varies with the elevation, but the cloud burst phenomena has been generally noticed. There can be some the other things, but mainly it occurs between the height of 2000 to 4000. Then, of course, in the hilly areas, various anthropogenic activities are taking place because of the population rise in the various states. For example, in Uttarakhand itself, during the last 2 decades, when the state came into picture, the population has increased a lot. Almost as in 2011, the population of the Uttarakhand is about 1.4 crore or 14 million. So it is increasing steeply, and people are moving up and up. Lot of developmental activities are taking place. Because of which naturally it is affecting the nature. Then deforestation is taking place again because of the anthropogenic activities, that the forest cover is changing, the land use is changing in the areas. So because of that, naturally the intensity of the rainfall is increasing and the runoff is increasing. Lot of soil erosion and the silt erosion takes place. Like some of the pictures of the anthropogenic causes, you can see it here. The lot of construction work is going on, and we move towards the rivers. And sometime when, because of the heavy rains, that the lot of damage takes place, like the dam construction, the hydropower development. Recently, we have seen that how landslide and the glacier burst has affected the area, and lot of deaths have taken place. Then if you see the major incidents which have occurred in Uttarakhand during the last 2 decades, lot of cloudburst and the flash floods has taken place in the various districts. Particularly if you see the Uttarakhand is divided into 2 major sections. One is the Garhwal, second one is the Kumaon. That this pink color, you can see it, this left side is the Garhwal, second one is Kumaon. And in these regions, the major rivers of the Garhwal region are Alaknanda, Bhagirathi, Bilangna, Dholi Ganga, Mandakini, Tons, Yamuna and Ganga. The major rivers in the Kumaon region are the Gori Ganga, Pindar, Sarju and Ram Ganga. And most of these major incidents have taken place in the upper districts, like the Uttarkasi and Samoli district. It has occurred in recently 2019, 2018 and 2012. In Pithoragarh, again in 2018 and 17. Tehri district in 2016. Rudraprayag district in 2013 and 1. So if you see that, just like in Samoli in August 2019, such a devastating flash flood occurred. And the incident was of the heavy rainfall, lighting accounted for extensive damage in the 2 villages of Samoli district. Samoli recorded 70 millimeter rainfall on 8th August, while the New Tehri got 30 millimeter rainfall. The heaviest rain was recorded at Nankesri and Kapkot, more than 100 millimeter as recorded. The major issue is that in these areas, even it is very difficult to measure how much actually the rainfall took place at that time. Then in Pithoragarh in August 2017, again there was a heavy flood. Due to cloudburst at Pithoragarh's Madkot, there was a flooding in the region and bridge got washed away. And at Dharchula received about 697 millimeter of rainfall in the month of August itself. So in Haridwar, the Ganga reached the warning mark of the 293 meters because of that. Then in Tehri, again, in May 2016, there was huge devastation, and the cloudburst occurred in the Kotiara, Sitakot, and Waleswar villages around Banganga region of the Ghansali block. And in 24 hours, the Nainital received 36 millimeter of rainfall, Pannagar 35 millimeter, Mukteswar 22 millimeter, and Tehri 9 millimeter. More than 200 houses and 100 animals have been reportedly buried in mud, while several roads in Ghansali and Chimyali have been blocked by the debris. So such type of devastation is taking place. And it has also been noticed that some of these cloudbursts have taken during the night time, where the people do not get any time to respond to such natural calamity. Then even we must be remembering that event or that incident in Kedarnath in 2013. The heavy rain took place during the June 14 to 17. The Kedarnath, this is the catchment area of the Alaknanda river basin, and Kedarnath is part of the Alaknanda where the Mandakini river is flowing. The area was about 45 square kilometer. The catchment of this Mandakini river at the Kedarnath is of diverse landscape and glacier adapted U-shaped valley. U-shaped valley and moraines indicate that past experience of glacier in the region. The elevation in that area varies from almost 3,500 to 7,000 above mean sea level. The leading land use feature is that snow is almost 75% of that area and responsible for the perennial nature of the river. And number of small streams approach the Kedarnath and the adjacent glacier. Just you can see the side of these houses near the Kedarnath temple, the Mandakini river. The topography and land use, if you see here, is that the elevation varies, as I just mentioned, about 3,500 to almost 7,000. The land use map, if you see that the more than 75% is the snow area only. So what has happened at Kedarnath was that more than 10,000 people died and over 1 lakh people got affected. The large number of livestock washed away. Hundreds of porters, over 2,000 ponies could not be traced. Loss of public and private property was of the order of $1,700 million US dollars. Because of this, then the various cities and the areas which got affected were the Karnaprayag, Rudraprayag, and Agastmuni, and Srinagar were the worst hit. This incident was also you can say that supplemented by the cloudburst in Fidogi village in the Nolti area, which caused the adverse impact on these towns. So what has happened is that it was noticed by IMD that during the time of 14 to 18 June 2013, at Tehri, Uttarkasi, Trali, and Jakoli, the rain was of the order of 381, 359, 326, 390 millimeters respectively. So more than 300 millimeter rainfall occurred during that. And on June 16, 17th night, a heavy rainfall of about 350 millimeter took place in the Kedar Valley. So accumulated rainfall in the Bhagirathi and Alaknanda catchments during the 10th to 8th June was found of the order of 550 to 580 millimeter respectively. So remote sensing satellite images of 18th May and 21st June showed that there was approximately 30% increase in the snow cover of that area. Just if you see the pictures of that area, that how it was looking before that incident and how it was looking after the incident. Just you can see the Kedar temple and that how the debris and the mud passed through that entire city. Fortunately, at that time, there was a big boulder at the back of the temple which saved the temple at that time. Just you can see the satellite images from the Cartosat 1 and Cartosat 2 that the locations at various places the road cut off took place, so people were disconnected from that area. These were some of the damages which has occurred during that time, and landslide near the Hemkund Sahib. Even the people were struck up. The roads were cut off from those areas. Buildings gave away, and that was the level of damage. Even the various bridges got washed away. You can see that Mandakini river overflowing the bridge. Then the flood hit area in the Chamoli this area, and then Rishikesh, that Ganga flowing above the danger mark in the Rishikesh. So that was the level of the damage. Then beside this, there were other list of the cloudburst incidents which has happened in the other Indian Himalayan regions during the last 2 decades. You can see that the various places. This is partial list of the various cloudbursts which has occurred in the other various states. One of the famous incident was in the Leh in year 2010. I would like to mention that that the incident location was near Leh, and the precipitation during in the afternoon was about almost 90 millimeter. Then again, between 6 p.m. to 9 p.m. it was 110 millimeter. Then almost the intensity was more than 13 millimeter per hour, and during the evening time it was more than 27 millimeter per hour. So intensity and the total rainfall both were the cause of the heavy downpour and the effect. Just you can see the pictures that how it damaged the entire area and the life in that area. That was one of the worst hit cloud burst in that area, in that system was there. So these were some of the incidents which has happened unfortunately in our country. For these, naturally the regions can be, we can say, the topography or the land use pattern, as there is very less or no vegetation in the area, in the Leh area. So surface in these catchments generally has less infiltration. The flood hydrographs in such catchments have high peak and very less time. Then the various, how we can determine the floods because of these various incidents is, we know that flood estimation we can do by different methods, like the empirical method, maybe Dickens formula or Ravi's formula or English formula, just for determining the peak. The rational method, depending upon the intensity and the area of the catchment. Then we have the statistical or frequency-based techniques, and then we have the unit hydrograph technique. For such type of incident, if we wish to assess what will be the hydrograph and what can be the level of the flood, we can use the unit hydrograph technique. For example, say in India, the Central Water Commission, they have prepared the various reports depending upon the homogeneity of the area. And for the ungauged catchment, these reports are helping a lot for assessing that what type of flood hydrograph can be there. Particularly in the Indian Himalayan region, the J&K, Himachal, Uttarakhand, these falls in the zone 7. And in the northeast part, the different zones are zone 1, 2A, 2B, 2C regions are there. So for each of the regions, the CWC has suggested the various unit hydrograph equations. So we can create the synthetic unit hydrograph, and on the basis of the synthetic unit hydrograph, we can assess what level of flood can be there depending upon the rainfall intensity which is taking place in that particular area. For example, say these are the different unit hydrograph equations for the ungauged catchment in the Indian Himalayan regions, like these, most of these J&K, Himachal and Uttarakhand are falling in subzone 7. So we can, if anybody is interested, they can find out the QP, time of peak, then the width of the at 50%, width at 75% of the hydrograph, and so on, and the total base. Like that, we can determine the various characteristics of the unit hydrograph in that area. So once that unit hydrograph is known, then we can find out the response of the catchment corresponding to any quantity of the rainfall, right? For example, like the Leh cloudburst, we have analyzed here, and depending upon the various method, depending upon the Mannings and in that area, depending upon the intensity of the rainfall, we can determine that what would have been the peak of the flood hydrograph, and what is the base, and what was the total volume of the flow which has taken place. For example, in the latest incident which has occurred just about the Josimat in the Banganga area, in Dholi Ganga and those areas recently, it is very difficult to determine how much volume and how much was the flood hydrograph was there. And people are mentioning that when the glacier broke down and the landslide took place, that occurred in the morning around 2:30 a.m. and it could only give the signal at the barrage level at 10 a.m. or so. So we were having the time, but because no information was available and the area was in the isolated area, so we couldn't do much in that one. Then it is not only the flow which is affecting. The main thing is that along with the flow, debris also flow. And particularly in the hilly area, when the flow starts at the top of the hill, for example, in this area also, again, the difference was almost of the order of 2 kilometers. And if a boulder starts at the peak of the hill, then you can imagine that what will be the velocity of that boulder. Maybe if I imagine that, let's say 1 meter boulder or 2 meter boulder, when it starts sliding from the top, and then what will be the velocity and change of momentum or the force with which that boulder is coming. And that boulder along with water, when it is flowing down.
Sir, sorry to interrupt. Sir, you have 2 more minutes.
Okay, yeah, I will just finish it quickly. So that force will be huge and that will cause a lot of damage to that particular area at the downstream. So one has to analyze that how much debris and the force with which it is coming there. Then my point is that I would like to conclude here about these events, that most of the cloudburst events are concentrated during the monsoon months, and majority of these incidents occur during the night time. The orographic lifting of winds cause cloudburst and consequently the flash floods. In Uttarakhand, vulnerability to disaster has increased due to various anthropogenic activities during the last 2 decades or so. The anthropogenic activities lead to the development of aerosols, which influences the Earth atmospheric layer radiation by absorbing and scattering sun radiations and further impacts the cloud formation. What can be done? Of course, it is very difficult to predict the cloudburst areas. Only thing is one has to prepare for such type of incidents and how we can reduce the damage. A dense network of rain gauges, especially in the areas prone to cloudburst, is needed for better understanding of this phenomena. The ground stations database coupled with satellite imagery can prove to be a powerful tool for the assessment of the cloudburst. Use of advanced scientific tools and techniques for prediction of the extreme events that will help in mitigating the effect of these such incidents. Then we should also have to control ourselves for the various anthropogenic activities, and one has to put the cap on recreational activities and stringent regulations to keep the check on illegal constructions. Then we should also train the local inhabitants on basic safety measures during the extreme events so as to reduce the damage, and we have to adopt the effective and strong rescue measures. I think these are some of my viewpoints on the cloudburst. These are some of the references in this area. Thank you very much.
Thank you, sir. Thanks, Consul sir, once again for giving such a wonderful presentation with title Cloudburst, a major disaster in the Himalayan states. Sir, really happy to know that, in fact, for the first time, I have understood that cloudburst occurs in the height of 2,000 to 4,000 meters in between. Then you have highlighted in your presentation, sir, regarding the Kedarnath incident. It's really it is a major disaster that India has faced in the recent times. Then you know that you have also highlighted about the various cloudbursts that is facing in the Himalayan region in the various states. And the before the ending, there you have highlighted about the debris flow also. I'm really interested to work in the debris flow related issues. So might be I will have a good chat with regarding this so that it can a good work can be done in near future. So, sir, some of the questions that has been asked us here, that one Mr. Muhammad T.M. Ahmad has asked one question that would you develop a flood management system or strategy? Can you share your PPT, sir?
Uh, Pardon, I would have read the point. Strategy for?
Sir, he was asking that would you develop a flood management system or strategy?
Yes, I think for the flood management system particularly in the Uttarakhand, they are going for having the strong information systems and the installation of the sensors in the entire Uttarakhand or the various river basins. Because unless until we have the strong data, we cannot have the flood management system for that. But I think work has been going on during the last, I would say, 5-6 years, and we are working for that one. Particularly the floodplain zoning, and even the courts are interfering in that one, that no activity should be carried out in the river basin, or maybe 50-meter or 100-meter from the center point of the river. So like that type of things keep on going, and there is a state level action plan they are thinking. So Uttarakhand is thinking on that lines, that how effectively we can manage the floods, right?
Thank you, sir. Thanks a lot. One of our participants, good friend of us, Basantaraj Adhikari from Tribhuvan University, Nepal, he has asked a very interesting question, that why most of the cloudbursts occur in night? Is there any relation?
To be very frank, not really I can answer that part, but probably when the daytime the clouds goes up, and then cooling of the atmosphere starts, and in night time when those clouds have gone down and it has become heavier, and because of the temperature difference, that the entire cloud burst and the entire rainfall take place. Maybe I think it is related with the temperature. Particularly in the daytime, the temperature is high and there is a pressure that the clouds are going up. And in the night time, when the cooling starts, it goes down.
Thank you, sir. One of our participants, Dipti Tyagarajan, has asked, what are the useful tools and simulation softwares can be used for flood detection?
For flood?
Flood detection.
Flood detection.
Sir, I'm repeating the question once again.
I think one can use the IHRR type of the software, where we can simulate the floods or the flood routing through the channels and the reservoirs, right? So one has to think of that. But again, most of these softwares are discussing about the water, right? So there is a need for simulating the boulders, because these are the rivers in the upper Himalayas. The large size boulders move with the water. So I don't think there is any mechanism, as I just showed one slide, that how the debris move, that the debris movement with large size boulders, and from what height it is starting up to what height it is going, and then when it is mixing with the other size, the small boulders and the silt and those things, how it is going to behave. So sediment movement or sediment transport, that is the area. And I think in Roorkee, lot of work was earlier done in the sediment transport area. But again, it is very, mathematics is very complex, and it needs some research in this area for this sediment transport. That's why I think you gave very good comment that it is very interesting if you people can join and do this debris flow analysis.
Yes,
and
sir.
if it has a more reliable results in the debris,
True, true,
that will be
true.
very useful.
True, sir. Sir, one of our participant had asked, actually, Muhammad Ahmad has again proposed something, but I'm not, he has given some suggestion or some submission. So might be I would like to message you his suggestion to you, because we have to take more questioners that is already in. So one is Mr. Prabal Das has asked, sir, is it possible to predict this phenomenon using artificial intelligence or machine learning techniques? Because mainly if we use AI/ML to determine extreme events, most of the time the values are underestimated. So how effective will be machine learning technique?
I think because this area, that was the reason why I chose this topic to discuss here. And so many learned people are there. And we have also started, we have taken few students for doing the research in this area, that how this phenomena is taking place for the cloudburst. I think it needs the three type of experts. One is the atmospheric science people. They can probably highlight this area, that formation of the cloudburst. As of today, there is no clear-cut science behind this, and one can predict the cloudburst. It is very difficult to predict the location of the cloudburst, right? The only possibility is that you are right, that artificial intelligence, if we have the information about the cloudburst area in this region, then probably one can think of the use of the artificial intelligence, and one can identify that, okay, this area is more prone to the cloudburst. But second part is that after that, if a cloudburst happens in particular area, how it is going to behave, let's say at the downstream, maybe 100 kilometer or maybe 50 kilometer, what will be the reach of that cloudburst if that happens in that one? And what is the land use, land cover in that area, or how much population is going to get affected by a particular one? That is the only thing which we can predict. And then we can make some sort of hotspot identification. We can identify the hotspots in that Indian Himalayan regions, that from the cloudburst point of view, and then what will be the effect or the damage. So some sort of floodplain zoning can also be done. Look, that this is the red zone, or this is the yellow zone, or this is the green zone. If a cloudburst happens, then at least there should be stringent rules that no people should construct like this type of in this area, right? The red zone, right? So that type of flood proofing or floodplain zoning can help us in mitigating the effect of this cloudburst.
Thank you, Consul sir. Thanks a lot. Actually, those who are having more questions, they can mail directly to the Consul sir, because you will find his email ID in IIT Roorkee website.
Get associated with the people and discussing these issues.
True, true, sir.
To do that. True. You can write me on my email. I have already given here. It's a very simple one. That is mlk@wr.ihtr.ac.in.
Thank you, sir. Thanks a lot for your nice talk. So, Dr. Srivalsa, you want to say a few words?
Fine, sir. Thank you, sir. I think we can move on to the next presentation.
Okay. Thank you. Thanks a lot.
Thank you. I think I can stop my sharing the screen.
Yes, sir. Yes, sir. Yes, sir. Thank you very much for the excellent presentation.
Thank you.
So our next speaker of today's evening session, Dr. S. Nilamani. Dr. S. Nilamani is a senior research scientist, Coastal Management Program, Kuwait Institute for Science Research, Kuwait. He got his PhD from IIT Madras in 1990 and was teaching in the Department of Ocean Engineering, IIT Madras from 1990 to 2003. He was the recipient of the Alexander von Humboldt Postdoctoral Research Fellowship, Germany, during 1996 to 1998. His specialization is coastal and ocean structures, ocean energy, and marine environmental issues. He has authored more than 300 scientific papers published in the reputed international and national journals and conferences. He also got 3 US patents as lead inventor during 2016 and many recognitions from around the world for these inventions. These two patents won gold and silver medals in the International Innovation Exhibition in Kuwait, Switzerland, and Germany. He reviews papers for more than 20 international journals in the area of coastal and ocean engineering. So I'd like to invite Dr. S. Nilamani for today's talk on coastal disasters and mitigation measures. So, Dr. Nilamani, the dais is yours, and please go ahead with your presentation. Thank you, sir.
Thank you very much for kind introduction. Thank you very much for also the wonderful organization of this particular event. I am going to present on coastal disaster. Right now, we were listening to disaster happening in the Himalayan hilly areas. Now we are taking you to the coastal area. Sir, please kindly make sure it is visible, the PowerPoint.
Yeah, please make it full screen, sir. It is visible.
Yeah.
Perfect. Perfect.
Yeah. The topic is coastal disasters and mitigation measures. So this is my email ID and WhatsApp number. At the end, if anybody wanted to contact, please kindly use it. The flow of the presentation is like this: a few minutes on how coast and ocean are serving us, 1 or 2 minutes on world of ocean, then we will enter into disasters in coastal and ocean region and suitable mitigations for different disasters. Particularly the focus is how climate change affects or modifies these disasters, different type of disasters we face in the coastal region. And I am also sharing with you a few of our studies related to coastal disasters in Kuwait, and I will conclude. But this is since many of you may not be from ocean related discipline, that is why a few minutes I wanted to spend how coast and ocean are serving us. Mostly the world love to live closer to the ocean. That is what the general feeling of people. Thousands of cities around the world, they are all like this on the coast, and people use coast a lot for sports, entertainment, fishing, whatnot. So even if you have a small stretch of land or small island, people always love to build house like this. So that is the way people wanted to hear the music of waves and the fresh air blowing on the ocean. They all encourage people to come closer to the ocean. Even the small hilly areas, people don't leave it. They build with houses, so they get a clear view of the ocean in the morning during tea time. The ocean is also, coastal ocean is used for a lot of commercial related activities like port and harbor construction. Apart from our own way of construction, nature has its own beauty with a lot of biodiversity, like what you see here and what you see here, the beautiful corals around the ocean, and what you see here with a lot of seaweeds which absorb the carbon dioxide emission a lot. It absorbs, apart from serving as biofuel and food for many countries like Japan, East Asian countries. Different type of seaweeds are main food for them along with rice. Also, I need not to tell about the protein-rich substance we get from ocean. Apart from all these things, ocean is a global air conditioner or cooler, whatever way you say. It takes the heat from the equator all the way to north and southern parts of the world and makes the temperature moderating agent. Imagine we spend a lot of money to cool our rooms in the home, and we spend a few thousands of rupees for electricity. For cooling of the whole, moderating the world, if you calculate the service ocean is doing, every day we have to pay billions of dollars every day. So that is the order of service the ocean is doing for us. Not only that, ocean also is a rich, very rich source of energy, many different energy. What we see here is ocean current energy, ocean wave energy, ocean temperature difference causes energy, like that, many different forms of rich source of energy, and people already started implementing, if not commercial level, pilot plant level, all the different type of energy system. People around the world started at pilot plant level. We are not far away from commercial level. In another 20-25 years, many of the ocean energy will become economically viable. We will all see that. So ocean, huge source of tidal energy, that is what in ocean. And you know, ocean has a huge is a source of solar energy in the form of temperature difference between the surface and deep water, especially closer to the equator. All the countries have this benefit. And ocean offers desalination, particularly for countries here in Gulf country. We don't have fresh water, we get the desalination. The main source of water is from ocean. Apart from all the things, ocean contains so much of rich medicines, unbelievably so much of rich medicines that will cure most of the disease we have today and the disease we are going to face in future. With that, because this encouragement is required to love ocean, human beings should love ocean. Not only talking about the disaster it is giving, we also should have a lovely feeling on ocean and coastal resources. The world has about 1 million kilometers of coast, more than 600 million people. That means around 10% of the people live within 10-meter elevation from the coast. Nearly 2.4 billion people, that is 40% of the global population, live within 100 kilometers from the ocean. So this shows how lovely we do with ocean. Almost 2/3 of the world's city in the world have population of more than 5 million and are located at the coastal area. The potential cost associated with the damage to port, harbors, etc. This is an estimate. It could be the order of more than 100 billion by 2050. This is what the cost loss expected due to sea level rise. Now we will see different type of disasters we face in the ocean and coastal area. Many are there. I am giving some of the important disasters the human is facing, starting from coastal erosion, flooding, either due to heavy rain in the coastal area or cyclone-induced storm surge, which is pushing the water into the coast, or tsunami-related water inundation. And sea level rise is another way of permanent inundation of the coastal area. Cyclone-induced disaster, tsunami-induced disaster, seawater intrusion into the aquifer, land aquifer, pollution, all the way from liquid pollution, plastic pollution, waste water pollution. These also are slowly becoming as a disaster. And then acidification of the ocean. All these things are major disasters. Some of them are by nature. God has built these things. And we are adding fuel to increase the disaster in most of the cases. One by one, we will see coastal erosion disaster is really one of the biggest disaster all the coastal country, including India, is facing. Nearly 33% of Indian coast is eroding. India is spending a lot of money to reduce the erosion disaster. So some of the pictures due to erosion is like this. The main issue is we are building infrastructure on the coastal area without following ICET of integrated coastal zone management rules, and we are inviting problem. This disaster is our invitation to nature. So different way of protecting erosion is starting from groin, seawall, geobags, stone-based seawalls, or offshore breakwater. These are all the prevention, man invented disaster protection. In some area it will work, and in some area it don't work. We have to select the right way of coastal erosion protection. based on clear scientific study. When we talk about the management, there are three things a human being has to keep in mind. One is, if already the infrastructure is in the coast, and if you cannot remove the infrastructure. Nowadays, many countries, they are trying to shift the complete infrastructure itself from here 100 meter or 200 meter away. In Philippines, some of the Netherlands, Mauritius, Indonesia, we have seen people shifting the whole infrastructure without destruction slowly, and then that is possible. If it is not possible, then we have to spend on protecting the infrastructure. So that is one way. That is already, if a structure is already available and if we need to protect them, the protection is possible only if the value of this infrastructure is much higher than the economy you are going to spend on protection. Then only this solution. And second, some of the infrastructure not existing right now, but we need to develop, and it need to be developed on the coast near the sea. If that is a compulsion, then in advance we have to take care of this infrastructure from erosion. How to do it? Either drive piles, deeper pile group, then build the infrastructure. So during sea level rise and waves, so nothing will happen to the infrastructure. So this is only if it is compulsory to make the infrastructure, like 5-star hotels on the seafront. They will only run the business if they have the hotel here. If the hotel is a few kilometers backward, then the business will not thrive. And third one is managed retreat. So we can plan in advance the sea level rise, and based on the slope, we can calculate the forward excursion of water. So if in 100 years, if it is exerting for 1 kilometer, then we can easily plan and build the infrastructure 1 kilometer away. Because by the time it is 100 years, the sea level will come here and structure loses its economical value. So that way, three ways of doing management from erosion. So then people started adding more substance to increase the efficiency of erosion by providing a lot of high friction substances, growing such type of substances, corals, introducing energy dissipating corals and stiff seagrasses in front of the structure. So this efficient way of dissipation is possible by using innovative solutions available. And from see, nowadays every country talk about setback lines, meaning from the high water level, okay, how far away you have to build different type of infrastructure. For example, a permanent high costly infrastructure need to be a minimum of 500 meters away. That is what ISSMGE rule for India and many countries, minimum 500 kilometers from high water line. Whereas other infrastructure which are less economical investment, like walkway or a small resting place or golf, such type of things, roadway, temporary roadway, they can be within 500 kilometers. Because even if sea level rises, there is not much loss of the economy for the construction of these type of infrastructure. So we have to plan, mitigation plan for sea level rise and associated thing need to be like this. So India, if you see the India, we have 7,500 odd kilometers of coast. If you see India, 33, see this number, 33% of the Indian coast is eroding. So that means more than 2,500 kilometers of coast of India is eroding. So we need to select right type of coastal erosion protection. On many occasions, by mistake, people select wrong coastal erosion protection. Where you have to build groin, people sometimes build offshore breakwater, and that accelerates the erosion. So we have to be very careful in selecting the right mitigation. That is one point I wanted to stress here. Then second is a coastal flooding. Coastal flooding can be either temporary due to heavy rainfall or storm surge, or during tsunami, or a permanent flooding during due to sea level rise. So based on temporary flooding or permanent flooding, we have time to think and act. The mitigation plan is based on that. For example, the cities with long life infrastructure, 100-year, 200-year like infrastructure, certainly we need to build only by assessing. For example, if life of the infrastructure is 100-year, in 100-year, what is the probable sea level rise and what is the permanent inundation? At least this basic information we need to assess before putting our infrastructure, permanent high-cost infrastructures. In many countries, flooding due to sea level rise, they have very well thought process like Netherlands. For example, they build dikes, impermeable, they are impermeable. The dike level, top level of the dike level from water level is order of 5 to 6 meters. So even if 1 meter sea level rise happens, the dike will not allow the flooding of permanent flooding of the rear side. So this needs a huge infrastructure to build, because the dike width is order of 60, 70, 80 meters. So it is very expensive to build impermeable and the erosion-free dikes. This is the cyclone history of India. East coast of India have experienced hundreds of cyclones in the last 100 years compared to west coast of India.
Nilamani sir, sorry to interrupt. Sir, please conclude within 5 minutes, please.
Okay, fine. So we have experienced a huge loss due to cyclone, particularly Odisha, Andhra, and Tamil Nadu. Scientific way of we cannot reduce cyclone intensity. So what we can do is we can build infrastructure which will not attract the huge wind force. That is a mitigation we can think of. Tsunami occurs once in a while. At least once a tsunami occurs, we have time to think, but we cannot move any infrastructure. So damage due to tsunami is very huge. Only way of reducing tsunami is, see, we assess the energy dissipation strength of tsunami, then make the dissipating system to dissipate the energy in the tsunami. So that is a scientific way of doing. Okay, even in some countries like Japan, they have an innovative way of reducing tsunami-induced flooding. And finally, the saltwater intrusion is another problem. It is there in every coastal city, even including Madras, Bombay, Calcutta, everywhere the seawater intrusion is there. But this is a scientific way of how to reduce the seawater intrusion. There are scientific ways available, so we need to do. Plastic pollution is another disaster, man-made disaster. We can talk a lot, but that action is required to reduce such type of disaster. And chemical seawater, the wastewater disaster is another one. But there are scientific way of discharging them to reduce a disaster. Okay, now I will just finally close up with this. See, if you see the chain of reaction, excessive greenhouse gas, if you start from here, this is what responsible for warming. That is what responsible for sea level rise. That is what causing then directly or indirectly high cyclones. And the increase in acidity is because of greenhouse gas. Reduction in biodiversity, loss of coral and mangrove because of greenhouse gas. So everything is connected in one way or other. So that is finally results in loss of biodiversity and human life and the economy loss. So we have to start very systematically. We have to start on greenhouse gas reduction. That is what the main thing for all the disaster reduction. This I was mentioning you, defense mitigation method. Only I will take 2 more minutes. Mitigation method is a defense, adaptation, and retreat. Whichever is feasible, we should adopt. Whichever scientifically possible, economically viable, we should adopt. And we also at individual level or country level, we have to think about these 4 R's. Like everywhere we are talking, reduce, reuse, recycle, restraint. These also we have to think with respect to reducing the global warming. UN decade, only 1 minute, UN decade of ocean for sustainable development, they have plans for clean ocean, healthy and resilient ocean, predicted ocean, safe ocean, sustainably harvested ocean, transparent and accessible ocean. These all United Nations is aiming to create systematic knowledge and transfer it to the world so that people take into account all these things, which directly or indirectly will help for ocean disaster and help us in mitigating many of the things. In Kuwait, we did the study for coastal inundation, coastal erosion, based on a lot of field work. We have produced maps which will tell you how much is the amount of inundation, hotspot for erosion, where will be the erosion hotspot. So finally, see, for example, for Kuwait, 1 meter sea level rise means 3 to 4 years of oil export. The money, that much of money is a loss only because of flooding, not cost of infrastructure loss. If we also think about that, it will be almost like 10 years of our oil export money is a loss. So like that, every country, it is possible to work out the economic loss. That is what is important for government to take decisions. That's why I'm giving this number. Economically, everybody will take action more seriously if you tell them this is the economic loss. To conclude, ocean and coast have many disasters. Mitigation plans are available. Innovative plans are available based on strong scientific approach and based on the economic level of the country. It is possible to reduce the disaster to some extent. But then on individual level, we have to think our carbon footprint. That is what the starting. So that is what will help in reducing the coastal disaster. Thank you very much for this opportunity.
Thank you, Nilamani sir, for giving us opportunity to hear you. In fact, I am sure that time was very short. I really apology from my my side as well as organizing committee side, because time is very short. But I am sure that if you allow you for next 24 hours, it will be finished, because you want to say so many things in a shorter period. So. So thank you, sir. It's something new that we have learned about, that is the coastal disasters and mitigation measures. And sir, we have heard a lot about the tsunami and all, but what we are seeing from your animation part, that the way that you have shown all these things, is really appreciable, sir. And looking forward to get more and more knowledge in coming days from some other platform from you. And now I'd like to take only one question, because we are running out of time. And just sir, one of the participants had asked this very interesting question, that what best technique for wave attenuation in coastal cities?
Pardon, sir, please repeat again.
What best technique for wave attenuation in coastal cities?
Best wave attenuation is if the country is closer to equator, 23 degrees north and south of equator, most of the places we have good corals, quality coral. So best way is to allow nature to grow more coral. That is the best way. Artificial way of protecting using seawall, they are not really better. But unavoidable situation, we have to go for artificial protection.
Thank you, Nilamani sir. And there may be some more questions for the participant. I'd like to request them, because sir has already shared his email ID. In fact, if you have his ID, I mean that his name also, so if you search the Google as well as his institute, probably you'll be able to his email ID again. So please mail to him directly, so that sir can give the maximum input to you. And thank you, sir. Thanks a lot. So this way we have concluded two very well-formed presentations as of now. So we have our third speakers now. It's Dr. Alejandro facility. Alexandra, are you there?
Yes.
Yeah.
Yeah. Can you hear me now?
Okay, thank you. Yes. So I'd like to introduce Dr. Alexander Faceti. Before that, I'd like to share his title. His title of this today's evening presentation is Multi-Scale Data and Physics-Based Modeling and Backward Erosion Piping in Flood Protection Infrastructure. Then a brief introduction to Alexander Faceti. He received his bachelor's and master's and PhD in structural engineering from the Sapienza University of Rome. In 2016, he joined the multi-skill computational mechanics laboratory at Vanderbilt University as a postdoctoral fellow. He recently joined the Department of Civil and Environmental Engineering at the University of Pittsburgh as an assistant professor. Dr. Faceti conducts research in multi-scale modeling of different composite materials for vertical and horizontal infrastructure applications. His work focuses on failure mechanics as well as durability aspects, combining multi-scale experimental information with in-situ and remote sensing tactics for real-time resilience assessment of large-scale infrastructure system. What I'm seeing that Dr. Alexander Faceti is quite experienced person related to the application of geospatial in infrastructure related issues. So I'd like to invite Dr. Alexandro to start his presentation in this forum. Thank you.
Thank you. Thank you very much for the kind introduction. So you can see the presentation, right? Okay, so thanks everybody. Thank you for the invitation. Very happy to give this talk today. So I will speak about recent research that we developed in the context of resilience assessment of the flood protection infrastructure. And I'm also very happy that this talk comes after two excellent talks that have been previously discussed. So there's really no reason for me to reiterate the importance of flood protection measures in the current scenario and in the current context for virtually every place in the world currently. So what we're looking at here is river flood protection infrastructure. Okay, so this is a massive type of infrastructure which is scattered massively along any country really, and this is a nice some nice visual graphics about how these structures fail. Okay, so if you see the top left picture, it's just a brief introduction of how a river levee works. Okay, so we usually have a trapezoidal core of the levee, which is funded on cohesive soil for impermeability, of course. And then usually the riverbed is constituted by intermediate sand and gravel. And so that's a much higher hydraulic conductivity down there. We call protected side or upstream side, obviously, the side of the levee, so the water side, while we call protected or downstream side the side that is protected by the infrastructure itself. Okay, so these are taken directly from the FEMA website, and so usually there are three modes of failure for this type of infrastructure. The first one is breach, which is basically a mechanical failure due to the load exerted by the water. The second one is an overtopping, which simply means that the capacity of the structure to retain water has been exceeded, for example, by a flash flood event like the ones that we have been discussing in the previous talks. And then the third one, is the so-called internal erosion, which is an erosion, which is an instability mechanism that happens underneath the structure. Okay, so this is particularly complex because while the two previous methods have precursor signs, so we can estimate when they happen, the internal erosion is really hard to see and monitor, and especially to operate in terms of maintenance. Okay, so this is particularly complex. So there's a lot of work that is being developed, that is being carried out in this field to try to understand a bit better how we can predict and act against internal erosion on the life of the levee. And just to give you an example, this is Internal erosion is accounted for approximately 1/3 of all the failures that are recorded worldwide for this type of infrastructure. So it is indeed a major problem. And I just want to show you very briefly how it works. Okay, so this is a simplified arrangement of a levee. Okay, so whenever there is any damage on the protected side of the levee, the toe, what we call here the toe of what will be the pipe, then has very high values of hydraulic gradient, right? Because basically the damage here on the cohesive soil relieves pressure, and so you have a high level of gradient, hydraulic gradient, that happens at the interface between the aquifer and the cohesive soil, and so these has the potential of eroding particles away from the downstream side to the upstream side. This is why we call this phenomenon backwards, okay? So it's a backward erosion mechanism. And so under certain circumstances when the hydraulic conditions permit, the pipe, so this erosion pipe, can undermine the entire stability of the structure because it can develop fully from the downstream to the upstream. And so the structure is effectively floating in this cross-section that we see here. And this can create, this more often than not, creates mechanical failure on the downstream side of the levee. So we started looking at this phenomenon. This is a really complex phenomenon, and it's a textbook example of a multi-scale problem. Okay, so by multi-scale, we mean both spatially and temporally multi-scale. Spatial multi-scale here comes from the fact that erosion basically happens at the scale of the grains, right? So the mechanics of erosion need to be discussed and described at the interaction between the interstitial water and the skeleton of the soil. But then the structural level, so the section, for example, the cross-sectional level, has some form of structural response that depends on a much greater scale, which is, for example, that in tens of meters that you see in the middle picture here. And then if we want to evaluate the resilience of the system, we have to think holistically, right? So we have to think about the entire infrastructure. And so here we're talking about hundreds of kilometers, okay? So there's these three very distinct scales that need to be accounted for and described with different levels of, obviously, with different levels of detail. And then the second multi-scale aspect of this problem is that of the time. So this is inherently multi-scale in time because erosion is a slow process that can happen over the span of months, really, while flooding is a very fast process that can happen in hours, really, or even minutes in some specific circumstances. So how do we tackle this problem? We tackle this problem with three different, basically with a general approach, which I will basically briefly discuss within its three main pillars. The first one is a physics-based model. So the first thing you do whenever you have a problem like this is try to figure out what's the mathematical model that governs the problem so that you can understand how it happens and what contributes to its evolution. The second approach, the second part of the research that I will talk about is the remote sensing part, where we apply different types of remote sensing to get better understanding and get more data to evaluate this, to evaluate the extension of this problem. And then we developed a data-based model, so a machine learning powered kind of model that is a surrogate model of the more complex numerical model for the microscale that can predict the state of the infrastructure at the global level, so hundreds of kilometers in real time. So I'll start with the physics model, okay? Obviously, I don't have enough time to discuss the entire mathematical formulation, but just very briefly, basically erosion can be in literature is generally described as a nonlinear diffusion equation, which is the first equation that you see up here with given Neumann and Dirichlet boundary condition, of course. Then we implemented a method, a multi-phase method, where we also enforce the mass balance, which is what you see down here in the fourth equation, which accounts for the passage of soil particles into the interstitial water as fluidized particles. Okay, and then this is the evolution law that we proposed based on experimental work that's available in literature. If you want more details on these aspects, this is published in Computers and Geotechnics, or please reach out to me and I'll be happy to discuss. How do we solve this complex system of equations? Well, in our lab, we have developed several approaches for the so-called random lattice modeling. So random lattice modeling is a numerical method for the solution of complex problems on lattices, right? So on 1D on networks. So this means that given a domain, we saturate the domain with points which are arranged in space randomly. And then we compute all the possible interactions between these points. So all the 1D elements that you see in the middle picture, which represent the behavior of the whole body. Okay, this requires some complex geometrical manipulation, but after you do that, then the interesting properties of this model, and that all the constitutive equations, all the partial differential equations that we use are solved on the 1D domain of each element. So this becomes easy because all the equations become scalar valued, and you can enforce very complex constitutive laws or very complex mass balance equations, for example, with relative ease. Okay, and this is the general arrangement, right? So whenever two nodes are connected by one of these network 1D lattice elements, they also share a polygonal area. Okay, and you can enforce all of the mechanical or transport properties equations on these discrete 1D assembly. So in previous years, we have developed many methods for really composite materials. Okay, so we have been working on glass fiber reinforced polymers, concrete, reinforced concrete, pervious concrete. In this specific aspect, to apply this to flood protection infrastructure and geomaterials specifically, we developed a new approach, which is called the dual random lattice model, in which basically we augment the description of this model by solving the problem on two sets of lattices, two different sets of lattices, which are dual to itself. Again, this probably would be a talk by itself, but the idea is we are developing an extended random lattice model to compute the gradients. So the hydraulic gradient, remember the hydraulic gradient we said is one of the main driving factor, really. Okay, and so we have developed these new techniques to compute the gradients with much greater accuracy, for example, than regular finite element methods. And so this allows us to describe erosion with much greater accuracy than traditional methods. Again, if you're interested in the details, you can find them in the paper that's listed at the bottom of the slide. Okay, so develop this model, a few validations. Okay, we start validations at the material level. So this is a mesoscale test, which is a simple flume test in which the upstream side water level is increased until erosion happens at the downstream. Okay, this is one of the most traditional type of experiments that is done in this context. Okay, and so we simulate these experiments, and this is the numerical results. So this is the evolution of the pipe, and you see this is a highly nonlinear process, both in time, because the erosion path basically is a complex path, and so the energy accumulation at the tip of the pipe is a complex function. And particularly the interesting thing that we observe in all the experiments is extreme branching of the pipe at approximately half to 2/3 of the length of the specimen. And this is interesting because this is also observed in literature, and so this is what is defined in literature as classic backward erosion piping. So on the phenomenological level, the model behaves correctly, so we are able to describe this phenomenon with a certain degree of accuracy. Now, on the quantitative level, we also used two sets of experiments, which are the very famous experiments conducted in Netherlands. The first one is by Professor De Wiet, which investigated the influence of the damage, so of the so-called exit condition, which means the type of damage that is experienced on the downstream side And of course, we see as expected that by reducing the size of the exit condition, the hydraulic gradient goes up because it's a singular point. Okay, so if you decrease the size of the singularity, you increase its magnitude. Okay, and so this is a subsequent validation of this problem on a macro scale test, but particularly in the Netherlands in the last 25 years approximately, there's been the so-called the ITK facilities. There has been a gigantic project funded by many different entities, which has tested real scale levies, so real life scale levies for erosion particularly. And so the authors there, they have tested four different soil types for the same erosion problem. So you have a levee, you increase the water level on the protected side, so the river level, until erosion starts happening at the toe of the levee, so somewhere around here. And again, this model was also proved efficient in the evaluation of the so-called critical head, which is basically the head at failure. Okay, good. So all of this is basically to say that we now have capability of representing erosion, internal erosion in river infrastructure with great accuracy, thanks to this model. Now, the problem is that you cannot apply this kind of simulation to the macro scale level because we just don't have enough computing power. It's a very complex problem that requires extensive computation. So how do we move from this understanding of the phenomenon to some form of operational management of the infrastructure? How do we inform decision makers or communities of the state of the infrastructure? For example, this is the unfortunately famous New Orleans levee that failed during Hurricane Katrina in the last decade. So how do we transfer this information? And this is the strategy that we used. Okay, so the idea here is that we can use a set of parametric models, right? We can parameterize the entire hyperparameter space, which is basically all the parameters that contribute to the creation of a given model. And we can train a machine learning model. We can train some machine learning, some specifically created machine learning with great attention, right? And then by doing this, we can predict by simple classification and regression stages, really, we can predict the most probable outcome for the given simulation without the need of performing the simulation. Now, whenever there's a critical state detected, for example, by the machine learning model, what we can do is we can go back and simulate just a small portion of the infrastructure just to make sure that the results are accurate. Okay, so this saves computational time by orders of magnitude. Okay, and I'll show you how. So the entire model, this entire problem is governed by these 9 parameters. Okay, and you see it on the bottom left there. And this is the way that it works. Basically, this is the general arrangement for all the parameters and what they mean in physical terms. So what we did here was we performed approximately 7,500 simulations and recorded all the results. Okay, and so we used 80% of these simulations for training, 15% for testing, and 5% for validation, as common in any machine learning approach. Okay, and so we developed this what we call multi-layer machine learning model because it basically activates different layers based on the results of the previous. And so, given a set of parameters, this is the important message here. Given the input parameters, we first classify. So basically, we assign a tag to the current state, whether or not erosion will occur. Okay, and so we can immediately detect. Why we do this? Well, we do this because if there's no erosion happening, then the structure is classified as safe at the given cross section. Right? And so there's really that saves extra time as well. If there is any erosion piping happening, then if in the classification stage we expect any erosion to happen, then we activate the second layer and we perform regression. So we also estimate by means of the machine learning. So statistically, we estimate the extent of the damage according to the given parameters. And it turns out that this works quite well because for the given data set that we obtain, then we get an overall accuracy of 95.5%. So we have a pretty good understanding of the phenomenon through the machine learning model, and we can compare the machine learning and the numerical predictions that you see down bottom right here, which are almost indistinguishable, but there's 3 orders of magnitude difference in the computation time.
Dr. Alexandra, I'm sorry to interrupt. You have just 2 minutes time.
Good. So this is the multi-scale approach that we use, okay? So since there's not much time, I will move directly to the remote sensing portion, okay? So we also used some remote sensing here. So we used both photogrammetry and LiDAR simulations to compute the geometry of the structure. Okay, so LiDAR is laser-based, so you're probably familiar with this technique, while photogrammetry is simply taking consecutive images and reconstructing a 3-dimensional object. So this is the system that we built, and we back at the time I was stationed, I was in Nashville, and so we performed a scan of this infrastructure, both from photogrammetry and LiDAR information, okay? And so we reconstructed the entire geometry of this very large portion of the structure, and we also evaluated both the geometry, as I said, but also we received live data from the river itself. So the river has several gauges, which are basically these 6 points, sorry, that you see in the picture there. And so we use the machine learning to download, basically we download these data live, and we use the machine learning to predict, okay? So we can perform the simulation of this gigantic structure. And we tested different scenarios that basically validated the system scale approach. Particularly, the second scenario is a random probability scenario, which identifies the area that are more susceptible to possible erosion failures. And the third scenario is the so-called local damage scenario, where we have localized damage that propagates from one point to its neighboring point, okay? So very briefly, let me conclude. So this is a general approach. So we basically trying to make sense of both physics-based, so a numerical model, and use it within a data-based approach to be able to predict the infrastructure behavior in real time with actual data streaming directly from the infrastructure. So this is basically an approach that can be used and leveraged in many applications to predict the state of the infrastructure with great detail, okay? And I will probably just skip this because we can talk about it in the Q&A session if someone is interested. But the message here is that by using experiments, numerical models, and data-based techniques, we can overcome the so-called curse of dimensionality, right? So we can finally obtain enough information at the infrastructure level to act promptly and also rigorously. So thank you once again for the invitation to give this talk, and I'm happy to take questions.
Thank you, Dr. Alexandra, for giving us so informative presentation. And I'm seeing that in your presentation, we are mostly dealing with the numerical modeling as well as the application of artificial intelligence and machine learning too. And sorry that we are running out of sight, and that's why we have to request you to cut short of your presentation. So looking forward to have more and more interaction and your topic probably by email or some other platform. So just we have one question that I'd like to take from one of our participants, that he has asked that in view of a poor data situation, how did you bound your loss function in your ML model?
I'm not sure what poor data situation is referred to specifically. So the models there use both support vector machines and Gaussian procession regression models. So we used basically what we could do there was force the uncertainty in the numerical model. That's basically the advantage of using the numerical models with respect to actual experimental data, because you can actually enforce a specific uncertainty within the material parameters and see the effect on the predictions itself. So in that circumstance, what happens is that you end up with a very rich hyperspace, really, and you can saturate specific domains. So what happens is that you can increase the accuracy for a specific part of the hyperspace. So that's exactly what we did. And there's actually much research in this in terms of enriching specific parts of the domains. We didn't get too much into that, but certainly having the numerical models allows you much more freedom in this context. And so this is a very rich data kind of problem in that sense.
Thank you, Alejandro. Thank you, my friend Aguri. So
thank you. Thank you, everybody.
And hope to see you again in coming days in some other meeting or some other conferences. So next, I would like to invite our next speaker. Will be the last speaker of our today's session. Dr. Penan Chinnaswamy. Penan Chinnaswamy obtained his doctoral degree with focus on hydrology from Missouri University, US. He has worked with Ashoka Trust for research in ecology and the environment, the International Water Management Institute, and the Nanyang Technological University, Singapore, as a scientist in hydrological applications. He is currently a resident professor with IIT Mumbai under the Center for Technology Alternatives for Rural Areas, and where his work primarily focuses on natural resources assessment, monitoring and management in rural regions. He is the founding director of the Rural Data Research and Analyzing, which is shortly called Rudra Lab. I'd like to invite Penan. I know that your time is a bit ahead of us because you are sitting some other country. So thank you. It's nice to see you that you are still there. So please start your presentation, and after your presentation, we will be able to have some talk related with some questions and all. Please, floor is yours.
Thank you to the chair and all the members who have invited me for this talk. I'll share my screen now. Is my presentation visible?
Yes.
Yes, visible. Can you make it the full screen, please?
Yeah. Okay. So in request of time, I have 15 to 20 minutes of presentation. So basically, my talk is on satellite-based analysis of groundwater storage and depletion trends implicating climate change in South Asia. So this was the work I started when I was with IWMI, with the World Bank South Asian Water Initiative project, but it still could not finish because of the data quality. So I'd go through that and what is the need for groundwater security, especially in India because of the venue we are in. So the outline would have some water resource issues in India, which is very basic, but very important. So I'll just brush through very quickly those things. And how has groundwater become the great buffer for climate change? Especially for farmers, because I work with a lot of farmers in Sitara, which is in IIT Bombay, very unique department just for rural development. And there we have seen that because of climate change, the most vulnerable people were the farmers, and groundwater is a resource they go to. So there is a need for holistic measurement and analysis of water resources. And currently it is very scarce because of the data issues. I'll come through some of the data issues. And we will go through some case studies done in India and across South Asia, and how this data has become a big problem for addressing climate change and even driving hydrological models. So before that, just small as the panel was mentioning, I had my PhD in the US where data was not an issue. And so all these models that we drove where almost, there's uncertainty, the bias and errors were less. But that is not the same case when we come to India. So here, water resources are very scarce because of the need and agricultural livelihood options of India and the population. So there's multiple things that are making India very vulnerable for climate change, especially with water. A lot of capacity is lacking, and that is because of we don't know what is happening. Water management quantity, but not quality. A lot of people talk about the quantity. When we talk about climate change and even the resources of water, there's always hint about the quantity, the volume, rainfall volume, but not the quality of the water, which is also getting hit. And that is where we need a holistic view of all these water resources to address climate change. Limited observations are there, and that is where remote sensing, as in my talk title, I will bring in some data that we have started to source. And Rudra is my lab, which is part of it. I'll come through that also. So climate change, groundwater has become the biggest buffer for climate variabilities and climate change delta changes. So if there is a shortage in rainfall, or if there is a big drought year, then people, agricultural or even domestic and industry, they go to groundwater. And because of this, India has become the highest groundwater extractor in the world, which is surpassing the groundwater which is being pumped by both US and China together. So 245 kilometer cube per year, which is still an estimate, but the numbers could go up as per the recent groundwater board reports and also the nature publications. There's a lot of disconnect between the deep and deep aquifers and shallow aquifers. So in hydrology, we discuss these in different terms. Shallow aquifers are aquifers where rainfall can recharge them annually, whereas a deep aquifer, sometimes the water is recharged at 100 years. In Nepal, when we were working with IWMI, we found that some of the water is recharged 100 years ago. So that is how long water takes from rainfall to come into the ground through the Himalayas, and then it comes as springs and natural discharge. So the references are given below, and World Bank is very, very important partner in this area where they look at groundwater development. And just for your information, they have promised a 1 billion grant for groundwater recharge activities just because groundwater is being exploited a lot. So what is the issues have been clearly mentioned, and what is the ways forward? So we need to not disconnect groundwater from surface water or climate change. It has to be connected together as holistic visions. My pointer is just playing around. Just try to stop it. So, so the mass balances have to be clearly mentioned, and most of the previous, distinguished speakers mentioned about the equations going into the mass balance. But before the equations, I put the data as more important because the data is very, very harsh to get, especially in our regions. What are the socioeconomic drivers? Why do we have these kind of incidences for groundwater or surface water depletion and anthropogenic stresses? Most of the floods are what we make. Climate change happens both in Kerala, where we had some papers in 2018, 2019, the floods record showed clearly that the rainfall was not above and below 100-year rainfall, but the flood volume was definitely above 100-year volume. Why? Because they have changed the land so much. And that is where the term comes, the floods we make. Okay, so that's the anthropogenic stresses. So there is need of a holistic approach. It's not just climate change, it's land use, land cover change, the human interface where they change the course of hydrology, and also the drivers that are causing this. So that leads us to a holistic approach. But once you get into this holistic approach, there's a need for big data. For just a small introduction of big data is a data which comes in high volume and high frequency. So big terabytes, petabytes, etc., and also in high frequency. Every day, every single week, we get remote sensing data, some of them, and some of them even in hourly database. So satellite data is one of the default big data that is available on the planet. So we have a lot of applications that can be done. A small framework is given. We'll go through that in the talk. So just to show that how this has helped in my Indian studies is I've used a lot of remote sensing platforms, and particularly GRACE for groundwater, which is the only satellite on mission now which can monitor groundwater. It is a proxy for groundwater, but still it gives a good estimate of groundwater resources. And I also used a lot of these other data packages for addressing the holistic approach, which is anthropogenic stresses, ET, those kind of things. And since I'm a government agency, like driven IIT, so we also used a lot of Indian Space Research Organization's data. So what we found is very clearly, this was a study done from 2002 to 2014, because that is when the GRACE mission was available. You see different climate data mapped for South Asian regions. This includes all the South Asian countries. And clearly you could see that rainfall, there's a big lag between the rainfall and the groundwater recharge. And that is because of the groundwater's hydrological pathway. Like it takes time for the water from rainfall to convert into groundwater. And this clearly shows when the monsoon season is and where the key abstractors are, which is ET. So ET is the biggest abstractor, and the monsoon season coincides with the evapotranspiration, which is the growing period of crops. So then we did the climatic analysis. When we did it for the plus 12 or 14 years, I would say, what happened is we plotted all the different parameters for the mass balance, the main mass balance, which is your discharge is equal to rainfall minus, ET minus groundwater storage minus surface water storage. What we found clearly is that the temperature is almost stationary. It changed, goes seasonal. That is where you see the sinusoidal curve. But your rainfall has actually increased over the past 14 years. Your runoff is almost the same, and it changes because of the nature of data we have. So rainfall, the runoff, I won't put more impetus on, but most importantly is the groundwater. So I've just taken it out for our clarity. Your rainfall has actually increased, a very slight increase, but your groundwater is steadily decreasing. And once you get down into the groundwater resources, the climate, and when climate change also adds in, then people are vulnerable, because that's where we get into this debate of climate change, right? Because people are vulnerable, we have to save people, and ecosystems are vulnerable. So this is where groundwater is clearly depleted, even though the rainfall has been increasing. Then we plotted it against the key extractor, which is ET, and we clearly see that evapotranspiration has increased a lot, and that is because of anthropogenic stresses, which is multiple cultivations of crop rotations, and also the green revolution for some part of it, where intensification of agriculture happened a lot over the past 20 years. So this is the case study which actually took data from remote sensing, and a lot of the government agencies, when we presented this was part of the World Bank's report, and when we presented it, government agencies, they said, okay, remote sensing we don't have still confidence in. So that is where we looked at building the confidence of remote sensing images. So we brought in data from GRACE and also data from the local groundwater board, which is the central groundwater board. We did a couple of maps. And what we found is the trend has been captured very accurately. The volume might be different, and there are reasons for it, but the trend of the depletion and recharge status has been clearly captured. If you just look at central groundwater board data, you would see that the groundwater board says that the water levels are decreasing, and at one point it stagnates and then becomes stationary. Whereas the GRACE data shows a complete depletion and still ongoing depletion. It was one of the first monthly estimates for the state of Gujarat. Why? Because Central Groundwater Board monitors only 4 times a year. You could see the 4 dots in the dashed lines, and that is the 4 dots of pre-monsoon, post-monsoon, and then monsoon and peak monsoon. So these are the 4 times they monitor, Groundwater Board monitors, whereas GRACE monitors every month. So these were the first images that were produced for the state of Gujarat, and we didn't stop there. We said, okay, let's go on further, and we mapped it with the cropping intensification. As I said, I used different packages from remote sensing, and we looked at different cropping areas and seasonal cropping. So we found that most of the areas where the crop has been 3 times a year, that is because of the agricultural intensification, the groundwater discharge has occurred a lot, or the groundwater level has been depleted a lot. But there are some regions where the groundwater has increased, and that coincided with the actual canal pathways of the dam constructed. So the dam's height was increased in the recent years in Gujarat, and we found a lot of recharge happening indirectly because of the canals. So this was also captured by the GRACE. And so these exercises were done to bring in sensitization and confidence in using this GRACE data, because a lot of people don't like that data. So then we looked at the number of wells that were, the number of pumps that were introduced in West Bengal. So in around 2005, the West Bengal government opened the groundwater market. Until then, groundwater cannot be tapped, but after that, the market was open. So if you look at the number of wells, it was almost stationary until 2005, 2006. And then after the wells picked up the orange line, you would see that the groundwater steadily decreased. Okay, so there was a big steady decrease of groundwater in West Bengal. So all these data, what has shown the remote sensing data is capable of producing data to support the recharge of groundwater and the discharge or the depletion of groundwater in different scenarios. So in the long term, we also looked at how rainfall and groundwater correlated between each other, and that gave us a lag time. So if in 2006 was a peak year for Rajasthan, we saw the peak year for groundwater a year later. So this gives a lot of details about the aquifer conditions, the porosity, the hydraulic conductivity, how the water moves, because these data are not readily available at a state level. You have some observations, but it has been taken a long time. So we did these maps. And because of this lag, we can recalculate the groundwater parameters. There are some papers that we have done with Australian professors where we clearly show how these water recharge and the lag time happens. And there is a big theme going on in India, which is the Ganges water machine. It's a very old theme, but they're trying to see how we could recharge along the Ganges. So basically pump out the Ganges waterbed, and then during the pre-monsoon, and when the monsoon happens, the water will recharge into the Ganges and store there. So, but for that, we needed estimates of groundwater storage, and GRACE was able to give that in very detail. And this project is still ongoing with the government of West Bengal through IWMI. So, but still, as I said, there was more data needed. And this is where we sparked this interest in students. We cannot just generate data, but can we use students and others interested to bring data? So like a crowdsourcing initiative. So we had this Mapathon event, one of the biggest Mapathon events conducted across the world. It was a joint effort by IIT Bombay, my parent institution, and ISRO, which is the Space Organization of India, and the AICT, which is the College Board of India. So they had around 2,000 to 3,000 colleges participating. So all these colleges participated. The beautiful thing is across India, we had people making maps for India, around 9,000 participants for 20 days. They brought in data, they went and collected data. So basically, the issue of using remote sensing data for hydrological issues is it's not ground truth well, or is it reflecting the current scenario? So that's where we use the students. We use the students from these colleges and produce these beautiful maps that no one has. And it was one of the largest event for conducting maps, and across all states of India were represented. Entire country especially, and it was only done with open source software, which is QGIS, which we promoted because we wanted everyone to have access to this software, and the data was also made available for them for free. So most of the data you see is expensive. You cannot get 1 meter resolution data or 10 meter resolution data, but now there are some satellites which are opening out. Sentinel is one, ISRO's database is one, which can give you some free high resolution data to do these hydrological estimates. So it was region specific and it was very intuitive. So what has happened is to address these groundwater issues and the climate change together, we need big data, and we should not shy away from using remote sensing data. And remote sensing has capabilities, but it also has to be used with observation data. So most of my papers that I've shown, all of them use observation data together with remote sensing data, just not remote sensing data. So this gives us an opportunity for holistic management, because holistic means bringing in all the stakeholders and all the partners that require this water resources. Better spatial and temporal resolutions were produced, and transboundary water management, because when you talk about Ganges, which is the biggest basin supporting people as per population, it supports 1 billion people. 1 billion, that's every person in the planet, 1/7 of the planet. One basin gives water. So what happens is, but it is a transboundary. It has Nepal in it, it has China in it, it has some parts of Bangladesh, and mostly India. So the data is not being transferred or shared. So these kind of remote sensing products breaks those boundaries, and we can do these climate change analysis, etc. Capacity for building at university level was also explored, as I showed in the Mapathon event. 2,000 colleges participated and produced a lot of maps, and which was very, very interesting to see. With this, I think my 15 minutes is over. So I would like to thank all the panelists and all the distinguished speakers for this. And I'd like to also acknowledge my partners who have given money for this. Thank you.
Thank you, Dr. Penan. Actually, your presentation are really wonderful one, and you know that as of now, we researchers used to face mostly the data, because data are not available, and those institutions who are carrying or they have the data, but they need some fee for it to provide this data. There's the one portion that if you come up with some innovative ideas, what IIT Bombay, then AICT and ISRO is doing. So if such type of things has come up, probably there are many researchers who can come forward to do some very innovative research using those data. Maybe in the coming days, we all youngsters, I mean not we actually, we are the senior one, the youngsters like you, as well as the black bearders of India who are coming in the next generation. So probably if we can come up with this type of idea, whatever you are doing, so it will be very useful for give a very good solutions for problematic as well as solve oriented issues. So thank you once again, and then if anyone has any questions, probably I do request them to mail directly to Dr. Penan so that he can reply you back. So now my part is over. I'd like to pass my floor to our organizing secretary, Dr. Srivalsa. Dr. Srivalsa, now floor is yours.
Thank you, Dr. Sarkar, for very efficiently chairing this session. I think Dr. Penan is there. There is one question in the chat box, it seems, if he is available.
Sure, I'd be happy to take that. So for the climate scale, climate data, so there is a website called CGIR climate data, where we used statistical downscaling for the climate indices, and it is free for all. Everyone can access it. And for the base and other things, we just used the normal raster calculators. Why? Because we wanted the government agencies to use it. If you make it too technical, they will not use it. Then the capacity is broken. As I initiated the talk, and as the panel chair I clearly explained, we need to break those boundaries. So to make it simpler, I just use the exact data, which is 1 by 1 degree grid, but the climate change indices were downscaled, and that is by CGIR, which is done by World Bank. I'll put the link down there. Thank you.
Thank you very much. Thank you very much. So my special thanks to Professor Raju Sarkar for kindly agreeing to chair this session and handling it very well. We are on time. So thank you very much. And this session I was also observing, we had speakers speaking on diverse topics like cloudburst, coastal disasters, erosion piping, and groundwater security. Even though actually I don't work, even I think all our field is different, but we see a lot of interest in these topics, and they have presented so well, so that even a common man can understand even the complicated things they have presented in a simple way. So we are very thankful to all the speakers, and thanks to all the participants. Professor Chandan Ghosh sir, you want to say something? We have till 3 minutes time. So because
yeah. No, nothing much to say, only to thank all the participants and our speaker that who have really opened up. I mean, I feel rather taking the umbrella of disaster risk reduction in National Institute of Disaster Management in India. After 15 years, 1.5 decades of staying over here, and then at this time that having such kind of conference and bringing such a diversified area that where our young generation can take years together to see the science, to look into the science and technology that involved, whether it is early warning, whether it is modeling, whether it is artificial intelligence. So it is really heartening to note that the presence of all the participants, more than 250, they're all together and then made this, that in fact what I have been trying, that I was taking a screenshot of various presentation over here and sharing it our institute website and institute WhatsApp group, where more than 80 people are there now working in NIDM, showing them that which are the versatile topic, like coastal DRR we have. Like, so in coastal area, what are the things being discussed at this level? That so those things, in fact, it is taking knowledge out of the knowledge and sharing it to the across the society. So that way, really, we are seeing a new horizon is coming up, and so we have a long way to go with the challenge that we have taken in the area of disaster risk reduction. And in fact, I would like to share that last 3 days, there was a disaster resilient infrastructure conference organized by India by Coalition for Disaster Resilient Infrastructure, which is one of the 2 UN organization, level of organization created by Government of India in September 2019. And now it has organized in the last 3 days. Today it is over at 6 o'clock. But there I have seen that more than 120 speakers were there from varied background who have spoken in the last 3 days, including our Prime Minister in the inaugural session and Prime Minister from Britain and also from Haiti, that they have addressed the inaugural session, and also a lot of UN organizations involved over there. So when I was checking that the keynote speaker over there and keynote speaker over here, I think if we go for standard deviation of their age, and so there's a lot of differences there. But I see that the diversified area that we, as a country, as well as a world, that looking into the disaster risk resilience and disaster risk reduction with the UN declaration, I think, yes, living is challenging, but we want to challenge through our science and technology. And that is how we want to not challenge the law of the nature, but challenge ourselves to live here happily. And in fact, tomorrow is the, Sival sir, tomorrow is?
Yes, tomorrow is our final International Day of Happiness too. Tomorrow is, so we are ending our conference on International Day of Happiness.
Yeah.
So before formally ending, let me just share tomorrow's keynote session. So tomorrow we have keynote session 9,
yeah,
and chaired by Professor Mizanur Rahman from University of South Australia. And we have 4 speakers: Dr. Neelima Satyam from IIT Indore, Dr. Kaustubh Dasgupta from IIT Guwahati, and Dr. Bhavani Rao, who is UNESCO chair at Amrita Vishwavidyapitham, and Professor Shuting Yang from University of Wollongong, Australia. So I request all the participants to kindly join tomorrow 9:30 AM Indian time, GMT plus 5:30. So thank you. So we formally end this session here. Thank you.
And
Thank you.
here, in fact, tomorrow, just let it not count for counting. Say it is not that 8 today, tomorrow is 9. Please remember all this. We have a special session at 6 o'clock there is panel discussion. So you will be all joining again in the panel discussion, special panel discussion, followed by a formal valedictory session.
Yes.
So you are most welcome, and tomorrow at morning as well as
morning 9:30. We have keynote 8, then 2 to 4.
2 to 4 is a technical session.
Keynote 9 in the morning and 2 to 4 keynote 10, last keynote session, and 6 o'clock Indian time, 6 p.m. the exciting panel discussion. We have a very good panel there with the very senior experts, recognized experts, and then we will have a closing ceremony and group photograph also. Informal session.
Yeah.
Thank you. So we formally end here. Anyway, we can continue our
informally. Yes, we can continue for some.